welcome everybody to the final and most anticipated talk of the night. Give it up for MacLemon and USB. How does it even work?
Thank you. It's so good to be back at BalCCon. I'm probably not the only one who has missed this place a lot in the recent past. Yeah, I'm MacLemon. You can find me on the interwebs. So I heard there's pictures of me from past BalCons. So I'm the one who foolishly thought to make a talk about USB. Then I recognized, no, this is probably like a 2 months workshop worth of content. So I limit this to a very foundational piece so that you know which rabbit hole to follow in the future. And after this talk, I'll be known as the guy behind the karaoke mixer. So it's all my fault. If you want to use social media, please use these hashtags so others can find what exactly you're ranting about. And so that I can get a feel for the audience, who of you has used USB? This is not a drug test. This is about technology. Or do you know someone who has done USB in their past? Okay, I see a few hands. I'm very interested in where the people live and how they live who have not shown a hand now. Because how do you avoid this stuff? Yeah, USB. It's an abbreviation in computing. It says Universal Serial Bus, a standardized technology for attaching peripheral devices to a computer. Is it? Well, how and does it even work? So we'll set the foundation for that. Computers, in the past, there weren't that many of them, and everything was good, but somehow the thing caught on, people started using them more, and people started to connect external peripherals to computers. So suddenly there was a need for receptacles or sockets, plugs that go into those sockets, and wires that connect those things together. So what do you need for connecting two devices together? You need an interface. An interface is a connection between two pieces of electronic equipment or between a person and a computer. It's also an interface. And it usually is comprised of a technical part, meaning a physical specification of a socket, of a plug, of electrical connectors, and the wires in between, and some kind of protocol, a spoken language that is common among the devices so they can understand each other. Interfaces can be unidirectional, meaning they're one way only. They can be bidirectional, meaning they go both ways, back and forth. And the current reality is that pretty much every interface is bidirectional. So what kind of interfaces, what use cases for interfaces do we have with computers? Most simple one you can think of is text input. A way to get some kind of text into a computer. Usually a keyboard. People were used to keyboards and because of typewriters before them. And it's been shown to be quite an efficient way to get text into a computer. So once it's in there, you usually do something with it and want to get it out again. In the past, this was a printer, maybe an impact printer, chain printer, ball head printers, something like that, page printer, and or even a pen plotter. You know those ones with large sheets of paper that draw lines? Very nice. If you have an old HP pen plotter, hold it dear. They're awesome machines. And later there followed monitors and TV screens, so like projectors like we use now. Then there's storage. Typing in is nice, getting it out again is nice as well. But in between, if you shut down the computer, you need some way to persist what you typed in, that input. It's very convenient because it saves you a lot of work. So you need a storage interface. That's, of course, bidirectional. You can read from it, you can write to it. One of the most commonly known one is SCSI, the Small Computer Systems interface. Small meaning a storage device that is smaller than the average washing machine at your home back then. And this is one of the very handy multi-purpose cables. You can not only connect computers with it. If somebody misbehaves in the data center, you can get rid of them with this as well. Depends on where you put it, but yeah. Other storage devices you may have heard of are like these ones. That's a floppy drive, 3.5 inches, so one of the later ones. And you may have heard of zip drives, jazz drives, SideQuests, all those weird things from the 80s and 90s. Yeah, floppies were a thing back then. So Windows, Microsoft Windows, the operating system still carries that legacy. Because why is your internal hard drive called C as a drive letter? Yes, floppies were A and B drives. And C is your hard drive. So we still see that legacy today. But we're focusing on external devices, not internal ones. Floppies were internal back then. And there's some optical input you would like. This is usually known as a camera or scanner to get some photo input, like photons detecting in a meaningful way and making an image out of it. So flatbed scanners, slide scanners, all these things. You may remember Linotype or Heidelberg if you've been into pre-press and producing papers or magazines, like this high with a large glass tube. It cost a fortune like a house, and it was slow as hell. But it produced decent quality back then, and still compared to today, it's decent quality. These devices also used SCSI-like hard drives. Then there's this weird category of barcode scanners. They're actually two devices. One that scans the barcode and interprets the bar data into numbers or letters. And then there's the output part, which is usually acting like a keyboard. So basically, if you scan a barcode, it types in what it reads. So that's actually two devices in one. They've been using many different connectors. We'll get into that. Also interesting, motion input. If a person moves, for example, with a mouse or a trackball, you want to translate that motion input into some kind of pointer. So that's also interesting. You may have used one of these in your past, joystick. Like many other joysticks, this one has a flat base to be safe and suction cups so it doesn't wobble around. So yeah, basically any kind of specialized input device will use motion input in some way. Networking, because computers do not only talk to other devices and peripherals, they also talk to computers. So what are the chart hits from the 70s, 80s, and 90s regarding connector types? Well, there's the subminiature or D-sub connector. You might have seen those like this D15. It's been used on monitors. The other end is RGB sync component. So this was a very odd cable. Or just a D15 monitor to monitor. That's not VGA. But you can use VGA as well. That's a standard 19-pin VGA connector with something else on the other side to connect some kind of display output. And regarding DIN connectors, there's, I guess, around 15 different variants of those connectors. And they've been around since 1915 because they have been used in cinemas for connecting audio when they started with film projection that actually had an audio track after you had a person at a piano playing to the movie. So these connectors are really old, but they're still used. And we've seen many different styles of uses for the same connector. Because this DB25, it's used in parallel ports, like that one. It's used in SCSI drives for storage. It's been used for serial connections. But it's all the same mechanical connector. Not electrically, though. So yeah, parallel ports, also known as Centronics, which is actually the company that invented that port. It's from the early 70s, 1970s that is, at least. And they were also used for serial connections and many other things. Registers jack, RJ11 and RJ45 being the most recognizable ones there. RJ11 was used for connecting keyboards to computers, but also for telephones. But who would ever think of connecting a computer to a telephone? Why would you need that? No, you can't mix them up. Surely that is not a problem. And they were readily available, they were cheap. You could just use them. And RJ45 yes, it was used for keyboards, not only for Ethernet and ISDN, so digital phone networks, and many other things. Then there's the famous DIN connector, DIN meaning Deutsche Industrienorm, like a German standards body for plug connectors. These are these quite large, bulky, round ones. And they come in 11 variants, at least the standardized ones. There's proprietary ones on top of that. Because why not? I mean, you can use them for keyboards as well. Lichtgriffe, like graphical scanners that would detect your electron beam on a monitor, on an analog monitor. Barcode scanners, MIDI, so you could hook up a piano via a DIN connector, via MIDI. You can find one of the Ataris that has these connectors in the Once Upon a Byte exhibition. You should go there, it's very interesting. And there's also Mini DIN, which is a smaller variant of that. Probably looks something like you cannot see from behind there, because it's way too small. And speaking of a standard, it's a little of a stretch because it's not really formally standardized. At least it's highly disputed who and when this was actually standardized, because I could absolutely not find anything to it. And the German standards body has no documentation on having ever standardized this connector. So that's odd. But it's used in variants from different numbers of pins, like 3 to 9 and some other ones. And they're used in Apple networking, local talk, 3D shutter glasses for your 3D movie experience, S-video, analog video, keyboards like PS2 and Apple ADB keyboards. If you have a vacuum, a Roomba vacuum, like an automated robot that cleans your floor, they have a Mini DIN serial connection on board, proprietary, and some ham radio and modem equipment also use them. So we're having quite a large collection of connectors by now, and some were used for many different use cases, so this is certainly the land of confusion. Especially if you wanted to hook up some peripheral to a computer, hey, it fits. And if you're lucky, nothing happens. If you're unlucky, you have a smoke machine, or two, at worst. And as you've seen with this cable, they're not exactly nice to carry around, or because people were carrying hard drives around like this size, because that's all they had. So yeah, these cables are not really nice to handle. And most of these ports were not hot pluggable. So the official SCSI implementation says, well, if you make any change to the chain, because you could chain these devices together in a row, if you make any change to that, you need to shut down everything, make the change, and then boot up again. Of course, adventurous natures were like, hang on, I'll just plug this in there and then have some special software to reinitialize the bus, and this worked mostly. But it was not officially supported. So if we do like an overview chart of what was used where, you don't actually need to read it. It's like pretty much every connector was used for almost everything. Except probably for the 3.5mm audio jack, that's mostly a thing of the past, sadly, by now. So we've identified a problem, a quite large problem. It does not make sense to use. It's pretty annoying to learn what thing does what and what works with what else. So 30-ish connector types of multiple variants each. We should make a standard, one that incorporates all the other ones, so we can come up with something that works for everyone. Does that sound familiar? Obligatory XKCD quote here. That is 927. You should not need to read that. You should know that. I see nodding faces, yeah. So, what to do about it? Well, as the third panel says, there are now one more competing standards for connecting peripherals. This is what happened. So in the United States of America in about 1994, a bunch of companies got together and said, let's do something about this, make this easier for users. Namely, this was Digital Equipment Corporation, or DEC. They were later bought by a company called Compaq. You might remember that one. Compaq itself was on that team as well. They got bought by HP. There was Nortel. They went bankrupt in 2013, so we're off to a good start with participation here. And then there's Intel, IBM, NEC, and Microsoft. Notably missing back then, Apple. So, yeah. But we upgraded USA to USB. And because everything needs a logo, we got a logo. It's the quite famous Trident logo. It's on many of the USB plugs that you stick in, and it should show which side goes up. Though there's actual knowledge-based documentation that documents the quantum state of a USB-A plug, that you have to like flip it twice to make it work. And usually this logo should be on the upside, but it's a should. And if you've read RFC 2119, you know should is open to interpretation. So the idea was universal serial bus. Work began 1994. Since Intel was on the board, you probably would have liked to write it that way. Hadn't they changed their own company logo to get rid of this lower E just a little bit before? And in 1990, they didn't write it that way. And in 1995, a year after that, they came up with pre-release specifications, 0.7, 0.8. And also the USB Implementers Forum was founded by these aforementioned companies, and they also brought out a USB spec 0.9, 0.99. Yeah, this is going where VLC version numbers were for a long time, adding nines. One 1.0 release candidate, and hey, because everything needs a logo, let's give the USB Implementers Forum a logo. Yeah, that's something. It reminds me of something else. Like vodka connecting people? Yeah, probably something for Rakia Leaks tomorrow. So, 1996 brought us USB 1.0. Have you ever seen USB 1.0 mentioned as compatibility somewhere? You have? Okay, that's one person out of the whole, no, two? Everybody else, huh? Three? Okay. A handful. No, most of it mentions USB 1.1. And it brought two connectors. Type A, that's a flat one, you know, from your computers, or I/O board on your motherboard, and the Type B connector, which is the more square one from a printer, probably. You've seen quite large ones. I oddly don't have that cable here. And the plastic parts were supposed to be white. Of course, supposed to be. Yeah, it's actually specified. Okay, 2 years later, 1998 brought us USB 1.1, and that's one that's often referenced. What are the reasons for that? Well, the first 2 years, nobody cared for the new kid on the block, and certainly not for the one on the I/O shield of your PC. There weren't any peripherals available because everyone was using the legacy connectors. They were already in use. Why get something new when everything else is there and works? So there was no incentive to create any new devices because consumers would not buy them. So it's a classical chicken and egg problem. Of course, from nature studies, we know that the concept of an egg is very much older than the concept of a chicken. So it certainly is an egg problem. So what could you do to make better market adoption of USB? Well, you need an egg. Specifically this egg. It was the Apple iMac. And Microsoft coined the term of a legacy-free PC. We'll come back to that. But it meant a computer that only had USB ports and none of the old connectors anymore. And this was the first one of them. Because Mac users back then were used to having SCSI for peripherals, ADB for keyboards and mice, local talk for networking. And the iMac did not have any of those. So like you could literally not use a single one of your peripherals that you already had, like nothing. It did not come with a floppy drive inside. That's why people had to buy external USB floppy drives. And to match the color of your iMac, you could, of course, change the faceplates. I mean, it's interior design, why would you not? And suddenly, manufacturers had an incentive because there was one computer on the market that could not connect to anything else. At least not without an adapter. So yeah, it had only USB, 2 ports of them. One was used for the keyboard, and you connected the mouse to the keyboard already. Either side was possible, so yeah, you ended up with 2 more ports. So legacy-free was executed painfully hard. So yeah, USB 1.1, as I've already mentioned, everything needs a logo, so why not use another logo for USB 1.1? I mean, consumers will love logos, and it helps them understand different things. So if we do an overview chart, we have USB 1.0, nobody cares about that. It specifies 2 plugs. Low-speed devices with 1.5 megabits of bandwidth, like a keyboard, mouse, like small peripherals, and a faster 12 megabit full-speed standard for faster devices like scanners, printers, and the like. Power supply was possible, 100 milliamps for a small device like a mouse, 500 milliamps at maximum. And each port must be able to provide those 500 milliamps, or you will get that message with, this device is drawing too much power, please disconnect it. Or if the computer was too slow showing that message, it would automatically shut down. What did people hook up to USB back then? Well, pretty much everything they could get a hold of, like a USB thumb drive with USB 1.1, meaning around 700 kilobytes a second of real data transfer rate. I mean, USB sticks were 8 megabytes, not gigabytes, megabytes back then, so it still took a long time. But people were used to having SCSI drives that were quite fast in comparison. So that's not nice. So a few years later, we said, well, let's do USB 2.0. That was the year 2000. 480 megabits per second of speed. That's a theoretical 50-something megabytes a second. A more practical 22. That's what is left. And we need a new name for that because, okay, if we have low speed, that's not good for advertising. High speed, that's already taken. Let's call it full speed. And since everything needs a logo, you get a new addition to a logo that you already know. And people need to be able to distinguish ports because this is faster. You need to advertise it. And then people started using tablets. And you could connect your tablet to your PC to charge it. Well, that's nice. The computer is the host and the tablet is the client. But what if I want to connect the USB stick to the tablet? Now the tablet would need to be the host. So we're closer getting to BDSM and role swapping here, because that's what USB on the go brought us. You could role swap, like a host could be a client and otherwise, depending on what they agreed upon. So, and it also introduced new connectors because, well, you have these A and B connectors, and but you cannot use a B connector on a host and A connector on a client because that would violate the standard. Well, let's make a new standard and introduce a mini AB and a micro AB connector that can go both ways. Have you ever seen a micro A cable? Not micro B like on your smartphone, micro A or mini A. I salute your kink. I support it. It's really weird. So our overview chart grows. So with USB 2, we have new logos, of course. Power supply is unchanged. To the very right-hand side, you see the colors. White for the old ports, black for the 2.0 ports. So somebody thought of, hey, helps the users. And they introduced new ports, and USB 2.0 got a revision 1.01 that nobody talks about, but it actually introduces the mini A and mini B connectors, as well as the micro A and B connectors. And they're also allowed on USB 1.1 devices, but you cannot retroactively fit them into the standard. So what do? You do an engineering change notice, an ECN, and say, well, for these old devices, you can just use them as well. So that surely helps consumers. But otherwise, yeah, 2.5 watts of power supply, it's still not a lot. People wanted to charge their phones, their tablets on the computer. They wanted to charge them faster. They also wanted to have more bandwidth for more demanding tasks and larger amounts of data. Well, introducing USB 3.0 in 2008. 5 gigabits a second. That's quite an improvement. Huh? We need a new name. High, yeah, we already used that. Full as well. Well, how about super speed? That sounds good. Well, let's call it Super Speed, give it a new logo, because, well, people love logos, and also give it a new connector. Let's call it Type C, because A and B and AB and on the go sounds a little like Microsoft version numbers of the operating system. Let's call it Type C. And Type C specifies the physical dimensions of the connector and nothing else. But new connections and new protocols require new pins, so those have 5 more pins than the original 4 used in the USB 1 and 2 connectors. So if we further expand our overview chart, you get at the very bottom USB 3.0, super speed with 5 gigabits a second. I'm pretty sure the types of connectors do not work out as a regular expression, because there's a Greek mu in there and you need to use UTF-8. It will not work, but you get the idea. There's a lot more connectors and a new logo, and they slightly raised the power that you could provide to a device. So yeah, your tablet would charge in an hour less than before, so that's nice. And also, there's a recommendation for USB 3 ports to be blue. Has a certain color code, make them blue. Not related to the 90s song where someone is blue and feeling dabba-dee, dabba-doo. But yeah, that's something. Don't trust the colors. Certainly, don't trust USB port colors for many reasons. But what do we do when USB 3.0 super speed is not fast enough? We double the speed. That's something that computer technology does. It doubles every now and then. Mr. Moore, please rest in peace, but it's not every 18 months. It varies by a large margin. But hey, USB 3.1, now you can have 10 gigabits a second. And we call it Super Speed Plus, because we can. It's certainly, I mean, a plus is certainly more than 5 gig. It's twice as fast. So we might add a little 10 gigabits a second, because consumers certainly know what gigabits per second means. They have a usual relationship, like how much is a bathtub? How many gigabits? Yeah, it's easy. So it will help consumers distinguish ports and cables and connectors. I've now got rid of all the USB 1 and 2 stuff, because that would be even more annoying. Our overview chart now looks like this. USB 3.0 super speed, 3.1 super speed plus with 5 and 10 gigabits. And pretty much nothing else has changed. Oh yeah, a tiny variation of the logo. And while we're at it, consumers might be confused by the naming. Let's just rename a few things. Make it more clear. So USB 3.0 super speed became USB 3.1 generation 1 super speed. I mean, do you have that cable? You know, the one for USB 3.1 generation. Yeah, sure. It's on stock. And
was that around the time when it got legal in the United States?
I'm not entirely sure, but and since it's always a great idea to introduce a new standard and immediately rename it, they did just that, because USB 3.1 Super Speed Plus became USB 3.1 Generation 2, though it was its own first generation, Super Speed Plus. Sounded like a good idea at the time. So, how did USB progress? Well, 3.2 came up. And you guessed it, a variation of the logo. That was around 2017. It again doubled in speed from 10 to 20 gigabits a second. So now it's really nice bandwidth. Keep that Super Speed Plus, because people like that. It sounds fast. Plus is more. By now, Plus is pretty much every subscription service on the internet, so, you know. And 3.2 also said, well, these old connectors, let's deprecate a few of them. Because, you know, the original problem was having too many connectors in too many variants. Let's get rid of that. But let's deprecate a few of those. So it deprecates the just earlier 3.0 and 3.1 introduced super speed A and B connectors with 5 more pins. The only recommended connector now is USB-C. But on motherboards, USB-A, though being deprecated, is still allowed and still in use. But we have an idea. Let's introduce a new color for those. I mean, the other slow super speed connectors and super speed plus connectors are blue. Let's make the new one teal. Yeah, I mean, it's an elegant color. That's obvious. And yeah, we could use that teal color for that one before as well, because I mean it's super speed plus, isn't it? So let's do an engineer change notice and leak that color back to your existing ports. I mean, it worked well the last time, so let's rename things once again. Yeah. So now USB 3.0, the original one, is called USB 3.2 Super Speed Generation 1. Okay. 3.1 became 3.2 Super Speed Plus Generation 2, still being its own first generation, but now in the second revision. And 3.2 got renamed itself to USB 3.2 Super Speed Plus Generation 2 by 2. Okay, now consumers need to do math before buying a cable. Okay, you're still with me? Why 2 by 2? Because they're now using 2 pairs of data wires to do 2 serial connections in parallel. So now the universal serial bus is also quite universal parallel serial bus at the same time. To make this talk not overly longer than I already will need time for, there is a USB 4 specification, and that's exactly how it's written, without a space between USB and the number, because spaces are weird and they cause all sorts of problems in file system names and path specifications, so let's get rid of the space. And yeah, that's a problem for future me and probably a future talk. We need to limit this somehow, and you will see why. If you're not already sure, yes, this needs limits. Also, you've seen slight variations of this, how much power can a USB port provide? Since many manufacturers came up with, hey, but our tablets need more power and stuff, and many manufacturers came up with proprietary solutions, and the USB implementers forums said, can we standardize this in some way? So they came up with the USB charging specification, which still limits most of it to 7.5 watts. So meaning 1.5 amps at 5 volts still, except when it's not. Then you can do 15 watts, but only for a USB-C connector on it. It's easy to grasp, you get it. And also that power problem was solved by using USB power delivery as a new specification on top of all the other specifications that make up USB, which is multiple thousands pages of freely available documentation, and that is great. So if you want to draw more power, I'm drawing the line here for power delivery, because that in itself is a rabbit hole. And enough for another talk. So I'll not go into that. It exists. It is really a good idea. It goes up to 100 watt with standard power delivery. Extended power delivery range is up to 240 watts over a USB cord. So cables will cause fires in the future, unless your cable gets a say in how much power is drawn over it. Future me problem. We've seen all the color changes. Have you thought about accessibility? I mean, accessibility with USB ports. Accessibility benefits everyone, even if you're not realizing that you're benefiting from it. Yeah? If you see a ramp, that's not only for people in a wheelchair. Side note, you can sing that at karaoke. So a ramp is not only for people in a wheelchair. Accessibility is also nice if you have a carry-on or some larger piece of thing that rolls behind you that you need to drag somewhere. You're not disabled, but it's really handy to have a ramp and not carry it around across the stairs. And that applies to many different aspects of accessibility. And color is one piece of accessibility that you should think about. Because around 13% of the worldwide population have a problem with recognizing red and green and distinguishing between those two. 13%, that's a few in here that probably have some sort of hard time distinguishing blue, but blue does not carry red or green. But teal, that has some green in there, and if it cannot, it becomes more or less two shades of blue. So yeah, accessibility, think about it. That's something interesting, because I certainly want to use that USB 3.2 Super Speed Plus Generation 2x2 port and not the other one. I mean, obviously. So, yeah, so would you like the blue one or the teal one? And have you even noticed that the color changed? Yeah. So yeah, accessibility, it works, and it's a thing to think about because people benefit from it. There's a famous song, She Comes in Colors Everywhere. So the port color might not be what you expect that port to be, and if it fulfills that promise it did not make to you. Quick guessing game. What type of USB port is that color? One something. Yeah, that's right, that's easy. One, okay. What color what color it is, yeah. It's a pretty absence of color, but what standard is that? 2-ish, okay, yeah. Yeah, there's 2.0 and 2.0 revision 1.01, yeah, it applies to both. That's correct. So yeah, USB 2 port. That's it.
USB 3.2 generation 1.
Super speed.
Together, you are absolutely right. To those having problems with the colors and the projector being absolutely able to display all 16 of the whole color spectrum. Yes, this is USB 3.0 Super Speed, also known as 3.1 Super Speed Generation 1, and also known as 3.2 Super Speed Generation 1.
Oh, but also 3.1 Super Speed Plus Generation 2 before they released the new one.
That's it, but how do you fit that on a slide? Then we have this one. Oh, huh.
That was a power delivery quick charge system.
Yeah, I think that's QI.
Ah, yeah. Something with power. Something with red, that's a good warning color. No, it's actually USB 3.2 Super Speed Plus Generation 2. Unless it is not, and we'll see why. That is that famous teal, okay? Who remembers the full moniker? That only.
Super Speed Generation 2x2. Also USB 3.2 Generation 2.
Before the renaming. That is absolutely correct. The currently correct name is this one. Huh? You'll get the slides, you don't have to remember any of this. Okay.
Oh, that's Qualcomm Quick Charge 3, I know. I have.
But are you sure?
I mean, it's a my machine.
Okay, so you're suggesting this is a proprietary charging standard by Qualcomm. It means that this port is either providing high current, not specifying by which proprietary implementation, or it's sleep and charge, meaning your computer can be sleeping, not being powered up or shut down, so some woozy state in between.
But it's not mandatory to have ports that can do that.
It's absolutely not mandatory. It's also not mandatory to use the color for anything. So, depending if you have connected your power brick to your laptop, this yellow port may provide power or not. It may provide more power or not, or it may not provide any power at all. Also depending on the charge level of your battery, disregarding that it's connected to a brick or not. So just try to find out, or get one of these. This is a USB voltage meter. You can plug that in and it will tell you what the port is claiming to deliver, and you can even daisy chain another device and see how much current it actually draws. These are available for cheap on well-known Chinese retailers. And they work pretty well. I cannot complain. So, one more. This is what the projector calls green. I hope you agree. And I'm really sorry, this means either your laptop was manufactured by Razer, who use green as an accent color for their branding, or it's Qualcomm Quick Charge. Because nobody requires any color to be used.
Also, there's orange ones by Xiaomi. Xiaomi charges are orange. Yeah.
Oh, yeah.
You're so close. You're so close. But first there's purple. So, this is Huawei, another proprietary charging standard. And this one's not only for USB-A ports, but now you get colored USB-C type ports as well. That's innovative. Huh? Where's the color? Yeah, it's purple. In Type C. Well, there's the very tiny separator in the middle. That helps. Yeah. Also a microscope or some kind of magnifying glass. You can take a picture and zoom in. Yeah. It's user-friendly. I mean, colors. Come on. What does that mean? Oh, we had red, didn't we? Huh? It should be red. Interpret this color as red, please. It can also mean high current or sleep and charge. So, yellow or red. And of course, yeah, there's orange. Oh, yeah. If you have a problem distinguishing the yellows, the reds, and the oranges, that does not imply you have a problem with color vision. It might be the projector. But if that happens often to you, you might want to get checked. They are the same, absolutely. I mean, it's totally the same. Video direction will approve they are the same color. Sure. See. Projector is always right. Yeah, this has absolutely nothing to do with power. It's a high retention connector, meaning if you have some device that has an orange port and you plug something in, it goes harder in, and if you yank the cord, you get the device flying. Yeah, and some chargers also have an orange and a green port, not having any of the properties just described. It's just because they're colorful. And because, I mean, there's a spectrum of people, there's a spectrum of colors. Can somebody please tell me what exactly that cable does support? What can you do with it?
Yes.
The answer is correct. The answer is yes.
It's an illegal cable because the iPhone connector.
I did not say it was a USB cable. It is a cable that we can agree upon. It is colorful and bright like the rainbow. That's also nice. It has 4 ends, which certainly violates the USB certification. And any of the ones even USB on the go. But they're €3 on AliExpress, and they probably also violate the laws of thermodynamics. I'm pretty sure. There's another cable. I know this is unfair because we're talking about external connectors. This one is solely used for internal connectors, and they come in colors as well. So that song, she comes in colors everywhere. The next line in the lyrics is, she's like a rainbow. And yeah, USB ports, they come like a rainbow. They're very diverse. And do not rely on the colors when it comes to USB ports. When people refer with colors, trust them, they know best which colored flag they are, and respect those colors. So now we have 14 different mechanical types of USB connectors. That's about half that we had before, so that solves the problem. But how do these devices talk to each other? I'll be heavily over time. So, topology. It's a so-called tiered star topology. Tiered star. Well, stars. Okay. Meaning there's a host controller and there's a device. And a computer can have multiple host controllers and multiple devices connected to them. And if you run out of ports, you get a port replicator or multiplier. It's called a hub, a USB hub. So you can get 3 or 4 or 7 more ports. Of course, you can put a hub onto a hub onto a hub. And you can cascade these until you end up with 127 devices on a single host controller port. Have you ever tried this? Because I would like to see pictures. I know a single company who actually did that, but
Also only 32 on USB 3. I also tried that.
yeah, there are other limitations applied. But yes, those 127 come from a 7-bit index for that thing. And so that the computer can learn about which devices on USB are connected, they're using something called enumeration. That is when a computer learns about a connected device. Remember, USB is supposed to be hot pluggable, meaning you can connect and disconnect devices and hubs at any time. Sometimes it's also interesting to disconnect and connect and disconnect and connect very quickly, because that will certainly help a computer to not get confused. And I've totally lost my, and since we have different speeds with the version numbers, a USB hub could be a USB 3 capable hub, but having a slow device somewhere connected. So hubs can also translate between speeds and deliver your keyboard input from a slow keyboard faster to the computer. Does not make a difference for the keyboard, but it makes a difference for the bus and how it's used. So how does this look like? We have a host controller, we have a device, and we have multiple connections. These are called pipes. And these pipes go from the host controller to an endpoint on the device. A device can have multiple endpoints, up to 32, 16 for input, 16 for output. Most devices do have more than one. Actually, all devices have more than one endpoint, but most of them just have a few. So physical devices, multiple logical devices. So far, so good. Yeah. These pipes come in 2 flavors, message and stream. A message pipe is bidirectional. It is used for control and status. So that's an organizational thing. And it usually uses very short and simple commands for this communication. So like a host controller says, hey device, got something for me? And the device, nope. Okay, that's simple messaging. Or a keyboard could say, well, a keyboard does not say anything because the host controller initiates communication and says, well, hey keyboard, got something for me? And the keyboard, yes, somebody pressed caps lock. Computer, okay. Hey keyboard, please turn on that LED on the keyboard for caps lock. And the keyboard, okay. So bidirectional communication. Your keyboard is an output device because it has some lights that glow, probably. And streams, they are for larger data transfers and they are unidirectional. They only go one way. So we've learned about transfers and pipes. Transfers always happen upon request of the host. It's like the pirate codex. Only speak when spoken to. A USB device on its own will not start talking protocol in any way. And these transfers come in 3 flavors. It's quite a tasty specification. There are interrupt transfers, there's bulk transfers, and isochronous transfers. Well, interrupts, that's quite easy. Human input devices, because they wait until somebody presses a button. Something happens. An event happens, and the device notes something happened, and the next time the host asks me, I should tell it to interrupt. There's something happening. So, because you don't want your keyboard or your mouse to lag, because you'll get fragged badly during a game. And latency on a USB 2.0 compatible keyboard is about 1 millisecond. So that's quite okay. Bulk transfers. Oh yeah, and interrupt transfers, they have a guarantee for a quick response, meaning they have a guaranteed latency of response on the bus. So they don't have to wait very long. So it's guaranteed that they will get their slot for a reply. A bulk transfer, on the other hand, they will get all the remaining bandwidth on the whole bus. Unless there's two of them, then they have to share equally. It's like a good relationship. They don't get any guarantees on bandwidth. Whatever is left, and we can share among all the devices. They don't get any guarantees on latency, so one might be quick if there's not a lot happening, one might be slower. But they do get guaranteed delivery, meaning, hey, there's a data packet, and everything is acknowledged. And if you get a non-acknowledged, so no, that didn't work out, then please resend it. And it gets resent until that works. So for storage, that is quite convenient that you know it actually ends up on the device. Makes storage more reliable. Unless there's buggy controllers, but they never happen. And then there's isochronous transfers. ISO meaning the same, and chronos over a certain period of time, so the same amount of data over the same amount of time, repeatable. They get a guaranteed data rate. So that's a fixed bandwidth they can use. They don't get a guaranteed delivery, so some packets might get dropped and lost. But that's quite usable for audio, video, because by the time you know, oh, I've missed some samples for that audio, it's already too late to retransmit them. It does not make sense to, like, half a second later replay the audio from ago. No, you just skip it and go on with the transfer. Same for video, like cameras, speakers, microphones. They do this, and it works fine. So now that we have a ton of different devices that we can hook up to USB, don't they all need drivers? I mean, yes, they do. But somebody thought of that and said, well, classes. I mean, classes don't work for society. They certainly do not work for subnetworks. I mean, like networking, yeah, well, that's a thing of the past. But device classes are a thing with USB. So to make implementations easier, especially on the driver side, USB specifies over 20 different device classes. And that device class is communicated by the device, that it's compatible with this specification of the class. And each of the multiple endpoints of a physical device can adhere to a certain class. So you can have multiple of those communicated. And the operating system will have a class driver for that specific one. So today you can just use any USB thumb drive as a storage and plug it into almost any operating system that's been around for a few years. And it will just work, no matter which manufacturer, vendor, doesn't matter. USB stick will say, hey, I'm a mass storage device, I adhere to this class, please talk to me. And this will work. So that is convenient because it makes development of devices cheaper, makes devices cheaper, makes maintenance easier, less bugs because operating systems with fundamental flaws hopefully get fixed, but some specific vendor that has a problem with one specific might never patch it. So that's a good thing. And one of the most important classes, I will not list all of them because there's a lot, is audio, of course, speakers, microphones, sound card, you know, the crappy USB ones you can plug in with the pink and bright green audio jacks on them, so more colors. Or MIDI controllers. You can hook up a piano, an electric piano via USB as an audio device. Of course, human interface devices, we know an interface can be between a human, a person, and a computer. So that's usually anything that's an input device. Keyboard, mice, tablets, trackballs, all these kinds of things, joysticks, something like that. There's also physical interface devices. These are actuators, meaning they can physically move something. So if you have a game controller that has rumble, yeah, if you get hit or drive besides the road, it will start rumbling, you can force feedback. So that's a motor that's doing the vibration, so that's an actuator. An actuator can also be a human interface device. Yes, there are USB sex toys. And they adhere to the physical interface device class, usually. So your toys are compatible with whatever your game supports, and you can just plug them in wherever they fit and what you're comfortable with. There's also USB mass storage, the already mentioned USB thumb drives, hard drives, opticals, SSDs, stuff. These classes can also get extensions. For example, mass storage was just used for plug in some storage device and use it, but you cannot boot from it. And since 2007, this class got extended, so for the last 15 years, you were able to boot a computer from a USB device. You may or may not have installed some operating system of your choice by that way. It's quite convenient, and it's possible that you find some old machine that does have USB ports, but they will not boot, and that's really annoying. But yeah, these things get extended and improved over time. There's also webcam classes for audio and video. I brought a very nice webcam here. It's where's the? Oh.
It's upright on the table. On the table.
On the table, upright. There, there. Yeah. Thank you. This one is not USB camera compliant. It's very proprietary. It's compatible with Windows 98 and Millennium Edition and a few others. And this is just a power bank. It's a very stupid thing. It does not record any video, so don't fear. It cannot send this anywhere. I mean, you cannot make it work on anything. And I'll hand it to the audience so you can just pass it around and see why this is the most annoying webcam probably on the planet. Yeah. So, yeah, and webcams, they use isochronous USB transfers because they drop a frame, well, nobody cares. There are other classes, for example, for hubs, for personal healthcare devices, that is not sex toys, that is pulse monitors, for Bluetooth, for serial ports, for biometric sensors like fingerprints, and any class-compliant device that communicates with a class-compliant operating system on that class, they can just be used and work. So that is very nice. A device can also communicate that it absolutely requires a vendor-specific driver and says, well, I use this class and this endpoint uses this class and this endpoint, yeah, no, you gotta get a driver. So you might have a camera that does work to get video and audio of it, but it might also have a gimbal that meets a specific driver, or it might work as an actuator, so depends. You'll see. So how do devices introduce each other? I mean, you can plug things in, but devices, we've learned, they don't start talking by themselves. The host controller initiates communication. Well, we have a bootstrapping problem. How do they start talking? Because the controller does not know about the device that's been just plugged in. And the device won't say anything before it's been talked to by the host. So, okay. There's something called signaling. And it varies by version of USB in quite a while. But for a very basic example, USB 1 and 2, they had 4 pins. One is 5 volts. You have ground, and you have data plus and data minus pins. Just these 4. And when you connect the device to a USB port, it announces its presence by changing the level of that data pin. Depending on the low-speed device, it will pull up D- to a certain level. A full-speed device will pull up D+ on a certain level. So that's simple signaling that the host can detect and notice, so, oh, something happened. And there's a few things working with this signaling mechanism. It does not specifically check which voltage level is there, because as frequency increases of that signaling, it's harder and harder to make out the difference on maybe a very small range. So what's actually getting detected is the change in voltage. So you have a rising edge, and that edge is easier to detect, especially at high speeds. And the falling edge, like the level dropped, not by how much, but it dropped, and you note that it drops. So this is the actual signal. The change makes the information. And there's a few statuses that can be conveyed, like detached. So, okay, D+ and D- are pulled down by a resistor on the motherboard, on the host controller, and it basically means, yep, nobody there. Very easy. you have a signaling that's called connect. Somebody plugged in some device on a port, and that's basically the device saying, hi, I'm here, I'm you, want to talk to me? And it immediately goes idle. So idle is the next state. Waiting, just looking, waiting for something to happen, someone to talk to me. And then we already heard about enumeration, so that the host can learn about the device, because by now it just knows somebody plugged in something on that port. And there's a reset signal. Since we have a one-to-one connection, host says, hey, reset. So let's start enumeration. So basically, I want to get to know you. Who are you? So then the device can answer with class specifications and the name and what it does. And it's actually nice that the first thing a USB device will convey to the host controller is what type it is, not in a machine-readable way, but in a human-readable string. So, hi, I'm a frog webcam. Because, and that is actually really important and smart. And you'll see in a moment. You can suspend the device. The host can tell a device, you go to sleep now. And the device will comply, or not. You can resume, meaning wake up. Host controller tells the device, hey, wake up. But the device can also wish to wake up. But it cannot do it on its own, because it has to be told by the controller. So it can signal, I would like to wake up. Would you like to tell me to wake up so that I can be protocol compliant and wake up? Then, yeah, host control, yeah, you may wake up. So, yeah. And there's also the keep alive signal, like, not really happening a lot, but nope, just stay awake now. And there's also, for higher level protocols needed, there's a sync message, a sync signal, sorry. It's like, here comes a new message. And I'm done with that message. So you can distinguish where it starts, where it ends. And that is also very convenient. So I promised you to, yeah. Why is it important that a device tells you what it's called in a human-readable string? Because enumeration is the next thing that usually happens after connecting. But what is if something goes wrong? Device says, like that frog cam, I need a vendor-specific driver. And your Linux computer says, well, you're not in my class of devices. So I can't do that. There's no driver for this thing. It can show you an error message and say, sorry, I cannot use this device. But this is what it's called. And if this is the 22nd different thingy you have connected, you know which one it is. Hopefully. I mean, who connects 20 frog cams? But it helps to have a human-readable string so that the person who connected the device knows that this one is not working and not something is not working. So that's a very convenient thing. So now that we have signaling established and can bootstrap a connection, there's a protocol on top of that. Yeah, so like actual language now. And there's these frames, and you can make packets out of those frames. And these packets can have different types for communication. So for a normal communication between a host and device, you have, for example, for a handshake, these four. They are type handshake in the protocol. So it's an acknowledge. Yeah, I got that. It's a knack. Nope. This does not work. Please repeat. There's a niet in a US standard. So I'm not ready to send the data yet. And there's a stall, so like something with that transfer is not working out. Something's wrong here. Then there's a packet called a token packet. And it shows you in which direction the communication goes, because the host initiates, so everything is from the point of view of the host controller. So an out transfer of data is from the host to the device. An in transfer is from a reply from the device to the host. There's a starter frame marker for synchronization, because we have a timing and things need to know when it happens, because we have a 1 millisecond timing with USB 2.0. And there's a setup. It's basically an out connection, but it's only used for enumeration. And that's also quite interesting because you need to address the device. There's also data 0 and data 1. They're basically the same. They're just used. One data packet is a data 0 type, and the next is a data 1 type, and the next is a data 0 and the data 1. And you should notice if something goes missing in between. I mean, at least for most devices, they can count from 0 to 1. Yeah. So, makes sense. And from all that protocol and signaling, we can do a transaction. So, connected a device, enumeration starts, and the host says, well, hey, device with that ID and that endpoint, I have a control message for you. It's called setup. Then the host sends the setup message, like, I've assigned you this ID, and device acknowledges, I've got it. But how do you address a device during enumeration? Like, how do you address an endpoint that you have not learned exists? Well, there's a special endpoint. It's ID 0, because everything should be 0-based, unless you're Lua. So during setup, it's always addressed to endpoint 0, and that one is only used for setting up the device. And it tells you, well, I've got these many endpoints, and they're that type, and it goes back and forth for quite a while. And this is also the reason why plugging in the USB device does not make it available. There's a lot of chatter going on, back and forth. And this takes time. And the more endpoints a device has, the longer that will take, because there's quite a lot of things happening. So, yeah. Then you might get a data reply from send some data to a device. Host says, hey, device with that ID and endpoint, I have something for you, start listening now. And then it sends the data, and the device, thanks, acknowledge, got it, wonderful, and your caps lock LED lights up. Finally, yeah. After a minute, tried that password. So the other way around, an in transaction from a device to the host basically looks the same, just the other way around. Hey device, prepare to send data, and hopefully the device is ready to send the data, sends it, and the host acknowledges, got it. So, USB, is it a universal solution brought? Is it really? The original problems was many different devices, connectors, plugs that were not fitting each other, variants of connectors. USB has only 14 for external devices. And most of them are deprecated by now with current versions. And that promise of a legacy-free computer, because sometimes we still need those old connections for whatever reason. Device classes, they make things easier, they make things cheaper, more reliable. They're a good thing. This helps a lot. Versioning and naming and logos within USB, I think complete clusterfuck is an understatement. I mean, for consumers, who can remember all those colors? There's more additions coming to USB, or are already there, but they're not within the scope of what I can show you here. There's Thunderbolt, which is basically PCI Express over that USB-C connector, but not really over a USB protocol. There's alternative modes for like DisplayPort. You can send video signals and USB and other things. So you have just one cable connected to your monitor from the laptop, and the monitor charges your laptop of a power delivery, and you get video out and speakers on the monitor and USB. So that's convenient. You just plug in one cable and everything should work. Mostly does. That's nice. And sure, this makes implementation of future devices more complex, more standards to be compliant, more problems that can come up. And cables will become a very critical problem, not only for users, but also for standards compliance in that regard. And it also leaves a lot of room for future talks on this topic. So if you want to join me or request something in the future from me, Legacy-free is a lie. It's a complete lie. I mean, we need those legacy ports. You've seen it, like video ports, very obscure video cables, RGB coax, laptops without Ethernet. I mean, who makes those? Okay, I'm using one. But yeah, you need those RG45 connectors. Yeah? They're important. Of course, you want a USB device that's compliant with your coffee mug. This is a heat plate. It's not very hot. Yeah. It's probably good to warm up. Do you drink rakia warm? No. Yeah, it's a very, very weird. You can charge your batteries from this toy, for example. That's my presenter remote. Yeah? Not to be inserted. And there's many other things that if you get too hot, you can get a fan. Yeah, that's a USB device. It only uses 5 volts, no data, so you cannot even know how fast it spins. But you need those legacy connectors, and I've brought one of those very legacy devices. Have you an idea what this is?
Either a light pen or an endoscope.
Both wrong.
Both kind of right, though.
I mean, you could insert it, but I wonder what you would do with it. This is a barcode scanner. Yeah?
Fuck, I used those at the library.
Yeah. When was that? What year? About? In the 80s. Yeah, that's about right. That device is from the late 80s. It has a few connectors because, you know, the barcode scanner is a camera and a keyboard. And it has connectors for Apple Desktop Bus, ADB. It has something called CPU. I have no idea what that is. It has a keyboard connector, RJ11, of unspecified pinout. It has another CPU connector with RJ45. I have also no clue what this is about. It has a DIN connector for keyboard and a PS2 connector for keyboard. You can still buy this device for around €100 or dollars, something like that. And since legacy is a lie, and I'm a Mac user, and we've learned that the iMac had no ADB ports, there's adapters for USB to ADB, so you can use an old Apple keyboard on your new shiny iMac. Of course, my laptop does not have any USB-A ports anymore, so I can use a USB-C to USB-A adapter, connect that to my USB to ADB adapter, connect that with an ADB cable to that barcode scanner. You've all seen that famous photo on the internet where you plug in devices by... This thing does not really work. I mean, physically you can, but that device at the end doesn't really do anything anymore. And yeah, we can connect this one here. And always a good idea to plug in a random USB device from the 80s into your presentation laptop. Please don't try this at home. So I have this.
Red dot? Yes.
Yes, you can probably see a red dot. It's not a very high energy laser, so I won't slice any one of you in half. And I deliberately brought a barcode. Okay? You just have to trust me from behind that this is a barcode. This can, in theory, read code 39, EN13, and something 2 out of 5. I can't remember the name properly. And now I should manage to somehow switch this and scan a barcode with this. And if I get that right, it types in the barcode I scanned.
Not on our screen.
Not on your screen. Okay, so I have not sacrificed enough goats or whatever is the current. Yeah. Hello. I can. It's always nice to have multiple screens and no idea where your mouse cursor is. So, okay. We'll take the scanner and move it across. And if you want to check, that's really the barcode. So if I find my mouse cursor again, I can switch back. Yeah. So legacy-free is a lie. We still need those old things. Smart card readers. Come up afterwards. There's a few more weird things here that use USB.
The floppy drives will work on your Android.
Probably yes. You can also hook them up to car stereos, and if you have an MP3 on there, you can actually play them. Usually, I didn't bring a floppy, but the Once Upon a Byte people with their excellent exhibition, I'm sure they can help us out. So, what does the future bring? Of course, Thunderbolt over USB-C. We've already heard that. PCI Express, power delivery. I've got the power, and it will be really interesting. USB 4 without a space, certainly. And there's already a specification for what comes after USB 4. Because USB 4 tries to fix some of the problems of USB 3.2 Super Speed Plus Generation 2 by 2. Yep. And the other ones that came before it and were renamed. So, if you get a vote, what would you call the next USB version?
USB 6. USB 5 hyperspace.
5 hyperspace. I've heard 6, okay. Any other suggestions? Just USB, okay. USB plus. Interesting. No, the actual, I kid you not, the actual name of the next USB specification is USB 4 version 2.0.
The question is not what you're going to call the next one, it's how you're going to rename the previous one.
Yes, yes. So, I'm left speechless. Who comes up with this shit? Thank you.
So I guess we're going to do a couple of questions, but not too much. And I will ask you to wait for me to bring you the microphone before starting the question.
Yeah, and just because there's a volunteer running around, thank you to all the volunteers who keep this conference running this year, the last years, and future BalCons. You absolutely rock. This would absolutely not be possible without you. So thank you very much. I hope you had at least some fun here. And also thank you to the BalCon Orga team for getting up a really awesome conference and keeping the community spirit up and running and not having us overrun by vendors and marketing people and salespeople. Let's keep it to the interesting hacking stuff and the community. Questions?
Yes, thanks. So you mentioned that the USB fan that you have is a USB device. So what is the lower limit for a USB device? Like if I plug in 2 wires in there, is that a USB device?
I'm not sure I acoustically could make out everything.
If I plug in 2 wires into the USB port, 2 bare wires, is that also a USB device? Like where does a USB device start?
From my understanding, a USB device starts at the point where it does signaling. This one does not do any signaling. It literally just connects the 5-volt to ground and runs it over a motor. So this is bang stupid. That's not a USB device. It just abuses the connector to get power. But those connectors, they're quite large. You could fit something in here and make something interesting out of it.
Yes, hi. Welcome back. Excellent talk. I still remember the previous one with storage is a lot of fun, the same as with this one.
Thank you very much.
Just one practical question. I suppose you have a lot of those cables. I have too. And when you put your hand in a box, right? And box is full of USB-C cables. How do you pick the right one with the correct power delivery specification, the speed and everything? Is there any practical advice how to do it?
The only correct answer to that is you don't. You don't just grab into a snake pit and pick the right snake? I mean, what about that octopus? USB-A, USB-C, Apple Lightning, micro USB?
Yeah, I have no idea.
don't.
So
You don't.
I actually started labeling them, so I know which one is,
Yeah.
which one supports what.
As I said in the future lookout with USB-C cables, there is next to no way for humans to distinguish what the actual cable is capable of.
Exactly, yeah.
Because with USB-C cables, you actually have a chip inside the connector.
Yep.
And that one actually gets a say in the negotiation between the devices at the end. So like a power brick, like this one, it can say, well, I can deliver 100 watts. And the laptop can say, well, I can use 60 watts. And your cable in between says, I'm a little shy today. I'd like to use 30, or I might go up in flames. And no, you have no way of distinguishing these just by looking at them. As a Mac user, I know Apple delivers USB-C power delivery power bricks with their current lineup of laptops. They deliver a cable.
Yeah, and
that cable is
saving
only
those.
usable for power delivery charging. It does not provide any user data. It only transfers the data it wants to transfer to negotiate the power delivery. But you cannot plug in a hard drive with it. It will not work.
Yeah.
And that's just because the cable says, well, I don't like you. And there's actually an Apple knowledge base article to distinguish the multitude of USB-C to C cables and how to tell them apart. And their actual suggestion is, well, there's on this mostly gray cable, there's a tiny code written in mostly gray letters, which after 3 weeks of use are no more existent. And by referencing that code to their knowledge base, it will tell you what this cable should be capable of. So no way,
hope. No hope.
Label them and hope that the cable actually does what the vendor or the AliExpress item listing claims. There's no way to rely on that.
Thanks once again and welcome. Excellent talk.
Thank you very much. You're only prolonging the karaoke party, so keep asking.
Very briefly, you said that, and I know that also, that USB 3C, whatever it's called, is actually carrying a Thunderbolt signal. And we knew that previously Thunderbolt signal was carried over the special cable on the Apple computers that were actually mini display port type. But the question is, as far as I know, USB, both USB and Thunderbolt are actually engineered by Intel, right? So my question is, as a Thunderbolt, is it just kind of a protocol inside the USB-C carrier, and that's how they operate, or?
Almost.
And are there any other kinds of a protocol also inside it?
Mm-hmm. Okay. So the question is, what about that Thunderbolt over USB-C connectors, and are there other things? So the cables you were talking about, that's one of those. That's a Thunderbolt 1 and Thunderbolt 2 cable. The connector it uses is the same connector, the same physical connector, as is used in mini DisplayPort. DisplayPort being a display standard for video signals, and mini display being a connector specification for that signaling. So this is just a cable. You can come here and look at it. Thunderbolt itself basically being PCI Express signals, like with a PCI Express card slot, that same signal just for external versions. Older Apple models did use this mini DisplayPort connector for Thunderbolt connections and DisplayPort connections. You can get an adapter from USB-C. That one can carry Thunderbolt 3 connections. And with this adapter, you get Thunderbolt 1 and 2 backwards compatibility, which actually it's only the physical connector used to it. So yes, you can do that. That works, not only with Apple, that's an Intel specification, so you can use it with PCs as well, if your operating system supports that. And with USB-C, you get from 3 point something, you get a way to run an alternative mode. So you get a USB connection, and the USB pairs the both ends of the connection can ask, do you support an alternative mode for using these wires? And one of these alternative modes that they can agree upon is Thunderbolt, and one other is DisplayPort. And that's how you get a monitor with only a USB-C cable that can do multiple connections, including charging. So this is the mechanism that's used there. It's one of the class compliance.
Yes. So my question was actually, so Thunderbolt protocol is not embedded inside the USB, but it's completely different signaling.
It's switching over the pins for that other use.
And
but the initial, as far as I'm up to speed with that already, the initial connection is USB, and it's basically talking to each other. Can we switch this port to this other one? And then they switch over.
And previously there was a FireWire interface, which was intended actually to speed up the communication between video devices that needed more bandwidth, which wasn't available at the time. And today we have kind of forgotten FireWire, which went to the FireWire 900, or I mean 9 pins, sorry, 800 megabits, but 9 pins. We have a Thunderbolt, and does the USB 3 or 4 or whatever generation or specification it is, do we actually need still Thunderbolt, or I mean FireWire obviously seems like a dead thing, but does Thunderbolt has some sort of advantages, because as far as I know, Intel and Apple were jointly developing the Thunderbolt for the sake of the high-speed storage, or I don't know if it's monitor as well. But it seems to me like it's kind of a competition between the Thunderbolt and the USB-C. So is Thunderbolt going anywhere, or is it going to be deprecated and into the USB 4, 5,
Thunderbolt
6?
is getting incorporated as an add-on to the USB specification as one of the multiple alternative modes. We're already there. You can already use this. This is a thing, not a thing of the future. This is already usable. I'm literally using it right now. And as for FireWire, yes, that was a great port. It was a great idea. It technically worked really well. The 9-pin, you can use that to a Thunderbolt adapter and connect FireWire with this nice abomination to your USB-C port, and that provides power as well. Yes, back in the time when FireWire was needed, USB could not provide the bandwidths and the reliability and all that needed for video applications. By now, USB has by large caught up and superseded what FireWire could do back then, and Thunderbolt goes way beyond that. So USB-C as a connector, USB 3, 4, and 4 version 2 as standards, and Thunderbolt will be the ones we see in the future and use, certainly. Okay.
Maybe I can also add to this that PCIe over USB or Thunderbolt, however you want to call it, is useful for external GPUs. So you can connect the GPU to your laptop. So that's one of the useful type usages where USB won't cut it.
Yeah, the question was actually, does it happen in the future as such, or it's going to be consumed by the...
No. That is certainly backed by multiple vendors and standards bodies as the thing to go in the future, and it's already here.
Guess that's it. Oh, one more. Okay.
One last question.
Do you think, in your personal opinion, that sometime in the future, divorcing from the term USB would be beneficial to remove all the confusion so far? So just call it something else.
Legacy-free USB.
You mean like renaming the USB implementers forum to something else?
Indeed, yeah. Just dropping the name and dropping the super speed and everything. Developing 16 standard.
I don't see that coming at the moment, but I also did not foresee the various renaming schemes for USB 3 and 4th. So, yeah, I would not rule it out entirely.
All right. Thank you, everybody. And go ahead and enjoy the karaoke.